Hey everybody, this is Luke Parisi and this is a Devblog on a 3 engine I've been working on recently. The goal with this engine is to eventually build a 3D game and that'll be my next release. I'm not sure what it's going to be, either an FPS or an ARPG, but at this stage I'm more just working on the engine itself and yeah. I'm still got to do a few more updates for Battlecorp before even releasing a 3D game anyway. Yeah, I'm just focusing on building this engine anyway at the moment. So what I've done so far, I've imported the UI from Battlecorp. As you can see here, it's exactly the same, which will probably change anyway, but yeah, it's just easier. Copy and paste all the code I've already done instead of having to do it all again. Yeah, same deal. Obviously a 3D engine, I can add more keybinds, like there's already crouch and jump anyway. Fire weapon isn't, space, jump is. So that's the UI, not much to show there. The 3D engine itself has been something new for me. There we go. So yeah, all this it's pretty much new. Instead of using, in the 2D games, I was using sprite batch and all that, but with 3D you use models. So these models here I've just created in Blender and just imported them into the framework here. So there was a bit of a muck around with importing models. The default model importer in MonoGame doesn't seem to work, open asset importer. So that was annoying, but I switched to this other importer, FBX, and it seems to import everything at double scale, so I've scaled it down and everything looks alright now. Yeah, this model here doesn't have any textures, it's just a 3D model with color. This one here I've put in a texture of, so it's just the tile set that I was using in Battlecorp. I've just put it on this cube here, which is, as you can see, it's see-through in some places. And backface culling is on, so that's why you don't see the back of this cube here, but if you go here you can see it. But if you turn off backface culling you can see every single face. But yeah, that's one of the optimization techniques I've started learning. Same with Frustum culling. So there was a big muck around because of the scaling and everything. So originally when I started working on the Frustum culling on this, say this block here, it was, if I look here, it would stop drawing it. And same like here, if I looked here, it stopped drawing it. But now I finally got it drawing and not drawing it at the right camera angles. So that's all new as well to me, is working with camera matrices and models and yeah, all the optimization techniques like frustum and occlusion culling. At the moment I haven't done occlusion culling yet. I've added frustum culling. As you can see, I had all the text come up so I could tell when the models were being drawn or not, but you can just tell anyway by the FPS. So as you look here, FPS is 90s, 100s, but if I look away, it goes to 170. And yeah, that's the frustum culling. So that's one of the things I spend a bit of time doing as well. So you can see these little cubes here as well. I've just added them in so I could see the edge of the bounding box. So that as well, that's what I was trying to figure out, bounding boxes, and for some reason, I'm not sure what I'm doing wrong, I was using tutorials to automatically generate the bounding boxes based on the model vertices and meshes and all that, but it wouldn't do it properly. So at the moment I'm manually pretty much in code just writing the model height, width, depth, all that as I create a model object. So I'll show you the code in a bit after going through some of the stuff in here. But yeah, so that's how you can see it's right at the edge here, the top edge there, and over here it's at the bottom. So, and that's by defining my own, I'm putting a model render class in, and yeah, defining model class in that, model object in that, and then yeah, creating height, width and that as extra dimensions and basing everything off that. So as well, if you look at the bottom of the text there's the is collide false, and then as I get close, is collide true. So that's just a basic collision with that same bounding box creation, and I've only added it to this just to make sure I was doing the collision right. So is collide true. If I jump too high, yeah, is collide false. So there you can see the bounding box is correct, collision is correct in that. But as well, I've added a simple gravity and movement system. So just WASD moves your camera position around, jumping, obviously cam Y goes up, cam pos Y goes up, and so on. So what you see on screen here, cam pos X and all that, that's your actual position matrix, or position vector 3, yeah. And cam X, Y, Z is what you're looking at. So as you look up here, cam Y goes up and so on. And yeah, so with that, generates camera matrices which determine what gets drawn to screen, and then that's when you can implement frustum culling and all that, backface culling. Well, backface culling, there's not much to implement, you just import that in. So yeah, as well, how the cursor remains centered as you look around, that's another thing. And yeah, at the moment, just the collision at y equals 0, actually it's y equals 2, I think, which prevents me from continuing to fall. And at the moment I'm just using control to crouch, and yeah, if it's less than 2, the y position, it doesn't allow you to jump. So I guess I'll go on to the code now. I'll switch to desktop mode and show off the code. So here, this is just all the gameplay screen. I've got simple classes for frustum, gravity, collision, your player, and all that. Pretty straightforward. Here I was learning to create objects directly instead of importing models. So here you couldn't see it, but when you moved in a position, it was creating just a simple 3D triangle on 3 vertices there, and then all the model importing there. So here, this is a new class I built which wraps the model, but then also adds position, the world matrix for the object, and a collision box, which is that bounding box, and these ones here which generates the collision box instead of doing all sorts of mesh calculations and that, which wasn't working for me anyway. Obviously, probably because I'm doing something wrong, because this is all new stuff for me. But yeah, at the moment, as you can see, I'm creating just a simple bounding box of the position minus the width over half, and so the min, yeah, and max there, and that generates a bounding box with the right dimensions as to how the model gets imported, and then draw that mesh as well. So here, obviously, if the model moves, which I was doing to test some model-to-model collision as well, but yeah, that's all working as well. And then just drawing the meshes and the model itself. And then here is another method of get distance that I was using to determine if it was going to draw the the model, if it was too far away or not, and then here the frustum. So yeah, all I'm doing. So I was using bounding spheres, but again, same with bounding boxes. The other way I was doing bounding boxes, bounding spheres, it always generates with a radius of 2. So again, I'm not sure what I was doing wrong there. But yeah, with frustum, pretty simple. It's just the view matrix multiplied by the projection matrix, which gives you what you're looking at and whether that intersects with the collision. So that can be a collision, not intersects with collision, intersects with the model. So here I'm using the collision box, but you can use the sphere. Yeah, I think you can use arrays in this one as well. No, can't remember. But yeah, so this is that simple collision box I was making there. So that's simply the frustum culling. So in player as well, if I go to player, I've just got simple movement as well. So here I've got an acceleration and velocity, and then the gravity's g-force in that, which applies a constant downward y acceleration, and then current airtime. So that I was using current airtime in that because when I first started implementing it, even when I was using delta time, what I found was the jump velocity would be completely different. It was either the airtime would be right or the jump velocity would be right at different frame rates. But yeah, so I got that working all along all frame rates. I'll quickly show that it'll be choppy on keeping it on desktop mode, but if you look here, so as I jump, airtime was 1.6, y velocity 0.4, and if I switch to, if I go back, options, VSync on, FPS is pretty bad because of the, because of the desktop mode. What happened to the, there we go. So if I jump again, air times again 1.6, velocity 0.4. So across different frame rates, the functionality, the movement functionality remains the same. So with all that. And there's also the camera control with controller, but at the moment I'm just using keyboard. So here, this is just the looking around. So the thing I'm doing at the moment, which I might change because I don't like, but it works, is with the Y axis for camera look. I'm looking at, I guess you would say it's like a line that shoots from your position upward and downward. So as you move your mouse up, the cam target Y increases, and if you look down, the cam Y decreases. And what I'm doing is adding a cap of 60 units upward and downward from your position, because I'm doing that because if I didn't, if you kept scrolling up when you were looking directly upward, the cam position would keep incrementing. So say you're looking up and kept incrementing it, and then you look down, it wouldn't pan the camera down, obviously, because the Y position is still higher than your current position. But yeah, at the moment, I guess it's kind of hacky doing it this way, but yeah, as I said, it works. What I really wanted to do was what I'm doing for the look left and right, and what I'm doing is I'm getting a rotation, an angular rotation here of on your X and Z axes, and then I'm doing a angle calculation here to get what the rotation of your camera should be. And what I wanted to do, so at the moment I'm doing that along the XZ axis. So I guess to explain it better, I'm creating a circle around your position of a radius 10. Well, yeah, I guess that's the best way to explain it. And then as you rotate, it determines where on that circle you're looking at, and then gets the angle that you should be based on where you're looking. So if it starts x is 0, z is 10, you're looking at a position 10 units in the z-axis in front of you. But say you move your mouse to the left, then that the temp x temp z will change. Say this will be 1.1 blah blah blah, and temp z would be 9.4, and then it calculates on those your rotation position. So here, and then that gets assigned to your cam target, which determines your camera angle. But yeah, ideally I wanted that in 3 dimensions. So instead of being this sphere, this circle of radius 10, I wanted a sphere of radius 10. So if you would look up as well, it would do the exact same functionality. So ideally, you'd have like float temp y here. I won't type it actually. And then based on those 3 floats, you do a rotation position calculation in 3 dimensions instead of your 2 dimensions. But I didn't know the formula for 3-dimensional position calculation. So this is what I've settled with at the moment. But I don't know if anyone miraculously watching knows the 3D position calculation or rotation to position calculation that I can use, then please. But yeah, so that's just what I've been doing. So that's your camera angle calculations there. Your movement calculations, they're real simple. Obviously, press W, move your position Z forward, move your target forward as well. Same with back and right. Sorry. So you move forward, it moves based on your rotation as well. So say you're facing directly along the Z-axis, then it will move your cam position directly along the Z-axis. But if you're looking at an angle, let's say 45-degree angle, so you're halfway between the Z and the X-axis, then it'll increment your cam position at a rate relevant to that rotation. So instead of moving one unit forward, it'll move it 0.5 on your Z-axis and 0.5 units on your X-axis. So that, yeah. And here you can see I'm using Y because in rotation position it's a vector 2, and I'm just passing in the Z-axis to the Y of the rotation position there. So yeah, that's along the 2D plane of the XZ axis. And then here, as you crouch, at the moment, as you saw before, it just didn't care. When I pressed Control, which is my key crouch, it just drops my Y position and Y target. But if I press Jump, I'm applying my gravity there. So I'm the difference here is I'm just moving, when I'm crouching, I'm just moving the cam. I'm just moving the cam position. Whereas here, when I press space, it increments my Y velocity by 0.5, which is it's like a burst velocity, and then you'll see gravity slowly lower that until it becomes a negative velocity again, and then hits the ground again, and then when it hits the ground, then it resets your velocity to 0. And I think I was saying don't apply gravity. Yeah, here. So here I'm saying don't apply gravity if your Y is less than 2. So yeah, and then as well, this is just a simple, I've done this today, choppy player bounds, bounding box to determine your collision with other objects. And then yeah, that's what you saw on the screen there. So collision is the same. I've just got this. I was using bounding spheres, but because yeah, I'm doing something wrong with generating the bounding spheres correctly, I'm just doing this, passing in two, I would say manually created bounding boxes, manually because I'm just passing in values I want to. And if I go to gameplay, I'll show you where I'm making the. So here you can see when I create a test plane, let's say, I'm creating the new model. That's the model itself made in Blender. So that's the path to it. And then I'm just creating the position where I want it. And then here I'm just manually inputting the dimensions I want it to have. So obviously I know this has the dimensions X at 20, Y 1, Z 20. So I'm just manually putting that. And then generating the bounding box based on that, as you can see here. So yeah, it's actually better on performance to do it that way than to do meshes, but obviously you want it automatically to create the bounding boxes for you, so you don't have to define the length, width and height all the time. But at this stage it doesn't really matter for me. So yeah, and then collision, I'm just passing in two bounding boxes. So that can be two model objects, let's say, if two models collide, or now with player bounds, which is a bounding box, I can pass in if the player is colliding with a model. So where is it? Let's see. I've just done, yeah, I'm just done a check on player bounds and the first plane. So if those two collide, and it's just a test to make sure I'm doing collision correctly. But yeah, as well, another performance improvement is, so if I go here, you can see I'm creating 2,500 ground models, 2,500 test cubes. So that obviously is a lot of objects. Now, I don't want it to always do calculations on those. So what I'm doing down here, if I can find it, in the drawer, in the update. So instead of using test cubes, I'm using these draw planes. So based on actually I'll talk about the test planes. So based on what planes, if they match, they're in the view. If they, I should probably do and to get distance, but for now anyway. So if they match the conditions, then we just add that to the draw plane list. And then before we add it, every cycle we're clearing that list. It might sound like it's bad on performance, but it's actually better because down here, what I was doing before this, I was running a sort of all so the sort here would be applied to 2,500 objects, and the more objects, the more performance heavy that sort became. So instead of sorting all the objects, I'm only sorting what gets drawn to screen, which makes more sense. And the reason I'm doing the sort is I want it to draw the furthest objects first and then the closest objects last, so that the closest objects appear on top of the furthest objects. If I wasn't doing this, it would just draw the furthest objects after the closest, and you would see the box. I guess the best way is to just to show it off. So let's just remove this reverse, so this will now, without that reverse, it'll draw. So if you look closely there, it'll draw the closest objects first, and then it draws the furthest. So if you look there, you can see that furthest object's being drawn after this one that's closest to the screen. Or if I look at something closer, let's say. So there you can see that object there in the distance is being drawn on top of this one here. So that's the purpose of that sort, is to make sure that based on the object's distance or the model's distance to you, it gets drawn last. So the closest things get drawn last, so that they don't do that. And yeah, that sort is fairly, even though I believe that uses quick sort, it's performance heavy when there's a lot of objects. So yeah, that's what I'm doing there. Sorting only the objects that get drawn to the screen. And yeah, I'm just doing it on those two. I'm not doing it on these. The small cubes were just to make sure I saw the bounding box. And yeah, this was the where was it? Not there. This one here was the object directly created, which was this one up here, the vertices itself, which you can do in MonoGame as well, which is pretty cool. But yeah, I'm most likely going to just use imported models, and those ones there are just the ones I just quickly created in Blender, because I don't know, I've never really done much asset creation in Blender or anything before. But yeah, down the line I'm probably gonna be buying Unity assets, Blender Unity assets or something, as long as they can be imported. And yeah, so that's currently what's in the engine at the moment, and the performance techniques that I've already implemented. So again, I know I have a bit to learn when it comes to 3D engine development, but it's been fun to learn. There's a lot of differences in 2D, like with the Frustum culling and that. It's pretty straightforward actually, but I was using something similar in Battle Court and even Lords of Delusion. When objects were off screen, I wouldn't draw them, but it works kind of differently with sprite batch than it does with model rendering. So yeah, with this stuff and camera matrices and all that, that's a new. Well, I kind of remember doing it in uni, but we did C++ GLSL, where I know MonoGame, which is XNA, and DirectX apparently is using HLSL, which is, from what I've read, it's apparently similar anyway, how it renders the objects. But yeah, that's all. I'm not too knowledgeable with any of that stuff, so I'm kind of just all learning the camera and that, which is pretty cool. So I was pretty excited to learn all this stuff. But yeah, next to do is occlusion culling, and probably playing around with adding a rotation float or something to this model render class, and then mucking around with create rotation, or however it works, and then animations, I guess, and then yeah, whatever else I can learn for performance optimization, and go from there. But yeah, guys, it's been a fairly long video. I was just excited to show off some of the stuff I was working on and what my plan is for this. But yeah, I'm still going to be doing Battle Court, and even last night I was thinking to even muck around with another 2D, making another 2D engine, and really going for high performance optimization. Like there's some things I wanted to change in Battle Court, like the enemy to enemy collisions, and at the moment it's just a I think it's called an n squared calculation, and that's bad because obviously when there's 100 enemies on screen, then that's doing 100 squared calculations on enemy to enemy collisions. Whereas if I can implement a coordinate system, a 2D coordinate system, then I can just have the enemies detect collisions on anything that occupy the coordinate or surrounding coordinates, enemies that are in those coordinates. So the collision detection becomes, instead of n squared, it becomes like, yeah, a lot better. And then with that, with the coordinate system anyway, then I could add pathfinding algorithms like A star, which I really want to get in, because when I was at uni, that was one of the things I didn't figure out, and that was mainly because of my understanding of coding was a lot less back then. Like I understood in pseudocode how I would go about implementing A star, but I just never figured it out, mainly because I didn't know lists well, and yeah, all the stuff that comes with it. But yeah, so that would probably be another thing I'd be working on. But yeah, guys, that's everything I wanted to show with this engine, and hopefully I can turn it into some decent 3D game. But at the moment, yeah, performance optimization is probably priority with this engine, because yeah, instead of using something like Unity, I'm actually building it myself, and if you are going for something you're building yourself, you kind of do want it to perform well. I mean, otherwise, yeah, you should use Unity, because then it'll just performance will be crap if I don't do all this properly. So yeah, guys, thanks for watching.